This is AP Calculus AB. I'm going to prove what the derivative of sine is. And in order to do this proof, we have no trig basis to do this on, so we have to use the definition of derivative, which is a limit as h approaches 0 of the difference quotient, which is the function evaluated at x plus h minus the original function over h. Now this seems simple enough, but in order to do this, you have to remember the sum identity for sine. Sine of x plus h, sum identity, is going to be sine of the first angle times cosine of the second angle plus sine of the first angle times cosine of the second angle. I can't forget to include in here this minus sine of x. And of course, this is all over h. See, from here, I can group this term and this term together. So sine of x times cosine of h. The reason I'm grouping these two together is because they have a GCF. Just rewriting the terms. Now I can GCF out of this. When I do that, I'm going to get the limit as h approaches 0. Factor that sine of x out. I'm left with cosine of h minus 1. Let's see, from here, I can rewrite this fraction as multiple fractions. I think you'll see why I'd want to do that here in a moment. It's going to have the limit as h approaches 0 of sine of x times cosine of h minus 1 over h. And I'm going to add to this sine of h over h times cosine of x. I have just rewritten how this looks. I think that you would agree that if we multiply this stuff together, so it's one fraction, and this stuff together, so it's one fraction, and I add it together, I would still get what I had up there. And this is an entire limit, so that should be in a grouping symbol. From here, we had some limits that we knew. If we evaluate the limit as h approaches 0, sine of x is unaffected by it because it doesn't have any h's in it. We learned earlier that, you know what, I got an extra, I apologize right here. I wrote sine of x h. This is just sine of h. Forgive me for that. We learned earlier that this limit as h approaches 0 approaches 0. We learned earlier that this limit sine of h over h as h approaches 0, that approaches 1. So now we have sine of x times 0, which is 0, plus 1 times cosine of x. That just makes that cosine of x. So in conclusion, we have just proven that the derivative of sine of x is cosine of x. So we could conclude from that that if we integrate cosine of x with mad props to x, we're going to get sine of x plus an arbitrary constant. Cool? Cool.